We're here to talk about sort of first-hand experiences of a very small startup and kind of going through the motions and the paces of figuring out what the right data storage option is was for us. This is not a talk about Cassandra supercolumns or simple DB performance. There's some elements of that, but if you're looking for really hardcore, what are the block writes speeds of HDFS or whatever, you aren't going to get that here. Instead, what this is more about is kind of our journey through the process and the mentality we had to have as we were exploring different data storage options. So kind of getting into this real quickly, who am I? For anyone in the back, if you can't see, that's me up there. And that was before I shaved my red hair. No, I'm also, oh yeah, and that was a picture in the arena over here. I'm from Portland originally, living in San Diego right now. But I am a Portland native, so if anybody's from Portland or thinking about moving here, it's a good city. So I work at a company called Newstar. Newstar does a whole bunch of different things, but what you might know it for is Ultra DNS is a DNS service they provide. Whoa, that's prompting me to go online. Sorry about that. Off that goes. Let's try to bring that back. Hey, there's the clown, and there we go. The business that I work in is Webmetrics, which is a website monitoring and load testing business. And I ended up there because Newstar bought my startup, a company called BrowserMob. Prior to that, I worked in the same industry for a company called Gomez. Before that, I was playing around in open source, so I do have some credentials here. I want to just make sure we understood that I do some open source stuff. I've been an active contributor for 6 or 7 years on the Selenium project. Prior to that, I moved to Portland for a company called Jive. Jive Software provides community stuff, and I got involved with them. It's going in and out. There we go. And I got involved with them. I can just speak up really loud if you'd like. All right, I'll just talk. I want to take this off and just shout. All right. If you can't hear me in the back, yell.
There's a podium.
Testing 1, 2, whoa. All right, and I got involved with Jive doing Java open source development. So if any of you use Struts 2 or WebWork, I apologize, but that was some of my contributions. Hopefully you're trying out some newer things these days. But that's kind of how I got here. And along the way, I dealt with some large data problems. And so I wanted to kind of share some of those. But real quickly, what I am not, this is why I warned you, is a big data expert, not by a long shot. So I'm sure there are plenty of other people you'll find here that can tell you all sorts of things about Cassandra and HBase that I could never tell you about. But what I can share is my experience going through this process. So what this is then is not an in-depth technical discussion, but rather it's kind of an exploration in pragmatism and evolution. And that's probably the really important story of this, is that as you're going through, whether you're a 3-person startup or you're a publicly traded company that's got plenty of budget, you're always resource constrained in some way. You're either constrained by budget, by people, by technology, by politics, and you have to somehow figure out what is the right tool for your particular problem. And it may not always be the one that is the best technological tool, but it may be the one that's the easiest to support, or scalable, or runs itself at night, or calls you up and wakes you up in the evening because you don't have an ops team. And so that's really what I want to talk about. As I've kind of gone through my career, I've seen quotes like these. Anybody ever hear this one before? Or this one, or this one. Actually, I just came from a Hadoop talk, and somebody brought up the name node, single point of failure. So I've seen all these different quotes along the way, and often they are said by people who don't really know what they're talking about. And I don't mean that as like an insult, because I'm sure a lot of you guys have said it. I've certainly said them. And it's actually not fair to say it's that they don't know what they're talking about. They may be experts on Oracle RAC or MySQL or Cassandra. It's that they don't yet understand all the issues. that come with picking these different technologies. It's like any technology choice. There's a lot more involved than whether the data storage system you're using is fully ACID compliant. There is supportability. There's how easy is it to set up and run on your laptop as you're doing development. There's operations. There's so many concerns. So it's mostly that people say these things like, well, we can't use HBase because it's got a single point of failure, so we must use Cassandra. And that's not because that's not true or not, but you also have to take into consideration, if you're employing one of the HBase committers and you're not employing a Cassandra committer, you got to take that into consideration too, and often those are overlooked. So it's okay that you don't understand all the issues when you're first getting into the project, as long as you're willing to try it out and evolve along the way. So with that, I want to kind of share a couple different product lines that we had in our startup, BrowserMob, which is now part of Newstar, part of the Webmetrics business line. And kind of tell you how we went through several evolutions of the product and ended up with a variety of technology choices for data storage. So we have two businesses. We have a website monitoring business, and that produces millions of browser samples a day, which are collecting hundreds of objects. You know, these are all the images and style sheets and whatnot that are on those pages for every sample. So we're talking about 200 million plus records a day being captured. None of it at any given moment is very high amount of data. It's a pretty small amount actually, but it's just growing and growing and growing. On the flip side, we have this load testing platform. This is where we're slamming your website with a whole bunch of traffic. We help companies get ready for Super Bowl ads or some big promotion, Comic-Con conference, things like that. And in that case, we slam it with a ton of data in a very short period of time. And we needed to figure out a way to kind of store both these different data sets and represent them to the customer in an efficient way. So it's important though, before I dive into both of these, remember I am not the data expert, and our company was just 3 people. And so that really influenced a lot of our design decisions as we went along the way and the evolution. So let's talk about load testing. So we started our business as a website load testing business, and we kind of decided early on we wanted a fireworks design. What I mean by that is we would bring up this, what we call a collector. It's the thing in the middle there, up into the Amazon cloud, and that would be the kind of command and control for the whole load test that was about to happen. It was dedicated for that customer's load test. And then it would kind of boom, explode out a whole bunch of additional machines around it that would actually generate the traffic. Not a very, super creative or complex design, but it worked pretty well for us. And that actually we stuck with from the very beginning, and it's still something we use today. The collector was where these agents, so the agents are generating traffic, hitting your site, and then every 10 seconds or so they'd send some summary data to the collector, and then the collector would aggregate it some more and it'd send it back down to the website, and then we'd update that to the customer. So what the customer got was a graph. So as the load test was running, they got a graph every 10 seconds, a little chart saying your website is showing 10-second response time, or now it's showing a 20-second response time. And it was in real time, and so it was pretty nice. And it scaled really, really well, because it was just in-memory aggregation. There was really nothing we had to do other than pull in these little slices of data every 10 seconds, roll it up, and send it down. The final data storage that we'd actually collect for when a test was complete was just 60 minutes of data and 1 little slice per minute. So it was 60 rows, even if we were spinning up 1 million virtual users hammering some site generated from 2,000 EC2 instances. So that was pretty cool. It scaled really well. Problem was that customers wanted a lot more data than the simple chart. We gave them like 4 charts and they said, well, now what? I want to drill down. And then we started thinking, well, geez, that means we actually have to collect the data, not just throw it on the floor. So we quickly evolved to version 2. I apologize if people don't know who the little guy is sneaking in the bottom right corner. I don't know, I had this nostalgia for Homestar Runner while I was putting my slides together, so Strong Bad makes an appearance in here. And if you don't know what that means, you should go check out homestarrunner.com. It's quite fun. So in version 2, we said, well, let's just throw a MySQL database up on the collector. So it's the same, fundamental same design. But instead of throwing the data on the ground, we'd collect it, and instead of those agents sending back just summary data, they'd send back the summary data, which would get aggregated up, same thing. And then they'd also send back everything else they saw, all the sample data. So that would include, potentially hundreds of URLs, the response time, the DNS lookup time, all sorts of, really rich and interesting data. And we just insert that into the database. Why not? And naively we just said, well, and if it's a bigger test, we'll just give them a bigger database. That seems to make a lot of sense. So, if it was a really large test, we'd use an 8-core machine with 16 gigs of RAM or whatnot. If it was a smaller test, they got a little half-core kind of thing. And so that worked all right. And then at the end of the test, customers wanted that data to download it and maybe host it locally, or we would spin it back up for them. So we'd do a little MySQL data dump and gzip it and send it up to S3, and that worked all right. And so that was good. We now allowed our customers to do really complex data analysis via SQL. Everybody knows SQL. We didn't have to go build a business intelligence tool. We didn't have to create, a new chart for every customer's need, and that really worked well for a 3-person startup. The problem is that now we were finding the collector was just getting crushed, because it turns out that you can't just keep inserting a ton of data transactionally into MySQL and expect that it'll just infinitely scale. So version 3. So we said, okay, well, let's tune MySQL. Maybe that's something we can do. So, oh yeah, Trogdor's here too. Sorry. I could have given you the same architecture diagram or a dragon with a beefy arm. So we tuned MySQL a little more. One thing we did is we said, okay, let's get rid of the indexes. Indexes are slow, that kills us. We'll add those after the test is done, because the customer's not really going to do any deep analysis in the middle of the tests, so we can just add it after the fact. So that helps speed things up. And we also appended the data. Instead of directly inserting it, we appended it to a big file, and then we bulk insert the file every 5,000 records or so. And that actually worked pretty well. That got us to about 30,000 inserts per second on some of the larger machines. And that was pretty good. That effectively maps to a load test that can generate about 30,000 requests per second. But who here has a website that gets more than 30,000 requests per second? I know one guy does. Netflix does. We have customers that sometimes get a lot more than 30,000 requests per second, and so that still wasn't going to work. And we went a little further, and I'll get into that in 1 second, but one of the simplest things we found we could do is we could just tell our customers, hey, why don't we just sample the data? Why not take 5% of the data? Do you really need to know how fast logo.jpg loaded on an individual basis for all 10 million requests we made over the last hour? We'll get representative samples. So we started bringing in sampling. And that's just kind of an important lesson in all of this big data stuff. Absolutely, try to capture every bit you can, but sometimes don't lose sight of the business reason for it. None of our customers were asking to see and look at every request that was made in the entire test. They couldn't possibly look through it when there's millions and millions of these things. They still wanted to work on aggregate summaries at some point. So that helped us scale up quite a bit, but still presented some problems. Sometimes customers were looking at the data in real time. We gave them, it actually looks like a terrible, terrible SQL injection hack if you use our product, because we actually give you a little window where you can type SQL directly into your own dedicated load test. And when I show people that, they say, wow, that's a huge security hole. And my response is, well, that's their database. If they want to drop a table, go for it, but you're just hurting yourself. So we gave customers that access to do some of that dynamic queries, and that was useful. They started using that because it allowed them to pinpoint what URL was really hurting them in the middle of the test. And sometimes they pause the test, go fix a little problem. Oops, we had a synchronized block where we didn't need it. Restart the app, resume the test, and voila, they can see the fixes. Unfortunately, because we didn't have any indexes, the queries that they were now running were just ridiculously slow. And we actually ran into a new issue. So we were serializing all this data from these agents. There's like hundreds or thousands of these things, all sending data back to this collector. And we were using a serialization protocol, something called hashing. If you've ever run across it, it's a Java serialization thing. And we were actually starting to hit this problem where the CPU was the bottleneck because it was just trying to deserialize that data. And so we actually weren't being pegged at 30,000 requests or inserts per second because the database was pegged just yet. We were getting there because we couldn't get the data fast enough. And so that's just kind of another lesson too, is you could have the best file, the best data storage system in the world, but if the code that's receiving it isn't actually optimized for receiving it at that speed, it's kind of worthless. You're bottlenecked there. So our next one, our next version was where we actually generated the insert statements on the agents. And these agents would write a big blob of bulk insert statements and then post that data directly to a servlet on the collector. And the servlet would pass it right through. It didn't read it into memory. It didn't try to deserialize anything. It just appended it to a file. We also started to be a little more diligent with multi-threading, especially because we were running 8-core machines. And we realized we could allocate a few more CPU cores to inserts. So before this iteration, we just had one background thread doing that bulk insert. And this allowed us to get 4, 5, 6 background threads doing some inserts. So that actually got us up to about 80,000 inserts per second, which we thought was pretty good. I don't know, has anybody gotten more than 80,000 inserts per second on a single MySQL box? I don't know, I've heard of a couple, but it's tough to get there, and definitely the machines are hurting pretty bad when they're at that level. And so we were reasonably happy with it, but again, queries are slow. In fact, they're even slower now because more CPU cores are pegged on doing all these inserts. And we were actually at a point now where we were collecting so much data during a load test. Then when the test is done, we did this MySQL dump, gzip it, send it up to S3 for archiving purposes. And that was taking like hours because a MySQL dump isn't exactly the fastest way to get data off the machine. There are some other ways to do that. We had this feature we added around this time where we captured screenshots and videos of clients that were participating in the load test. So the name BrowserMob comes from the fact that we kind of throw a lot more hardware at the problem than traditional load testing does. We actually run real browsers, and that comes from my Selenium influence and background. But one of the nice features of that is that we can get you a video or a screenshot of a failed transaction. And so you get to see that nice, Ruby on Rails like blow up inside the screen, or your Java Tomcats stack dump that's printed out. And customers really like that, but we realize that that's a lot of data too. If we have 2,000 to 3,000 browsers, and actually I just looked at customers running a test right now that has about 2,000 browsers slamming away on their website at this exact moment up in the cloud. And we're capturing a video of each one of those. And that's a 50 megabyte video. Every time we do a sample, and the samples last about 30 seconds, that generates a whole ton of data. I was actually getting to, in some cases, we saw about 20 terabytes of data per hour being just thrown down onto these local disks, but we couldn't possibly store that. S3, I suppose we could store it there, but then our margins would be totally screwed because we were trying to be a low-cost load testing vendor, and the cost of that storage is still pretty high. So we only captured the first screenshot of a particular unique failure. So when on line 17, if a page timed out, we just capture that one screenshot and that one video, and then any other timeouts on line 17 would not capture a screenshot and video. And that worked reasonably well, except for when somebody had a different timeout that was caused by a different reason and they couldn't understand what it was. So that was kind of a problem as well. So we went to version 5, and that's where we are right now. And we started bringing in some of that sampling, going back to kind of one of the earlier aha moments where we should just sample the data. We realized, why don't we just predict what the sample rate should be ahead of time, communicate that to the customer, and they seem to be pretty happy with that. And so that was kind of part of our evolution as well. So if we see that you're going to run 1 million concurrent user tests with us, we'll just say, okay, we're going to sample 2% of that data. But you'll get it, it'll be quick, you can access it in real time, run MySQL queries, and it'll be very representative. We also capture all failures because failures are always interesting, so we don't drop those on the floor. But the MySQL data dump was a problem for us. When you're trying to dump a 10 terabyte database, and then gzip it and upload it, that machine could be hanging around for 5 or 6 hours or more trying to get that all done. Plus you had issues with how much ephemeral storage was actually attached to the machine. So what we realized is we needed to use something like Amazon EBS. So anybody here get burned by EBS recently? Yeah, we got a few hands up there. Yeah, we got burned by it too. I'll get to that in our monitoring system. But what we're starting to do is actually attach EBS and just connect multiple volumes, put our MySQL database on that. The writes are actually a little slower now, but we can just snapshot those volumes, and we don't have to do a database dump. And so when a customer wants that data again, we'll just spin up a small MySQL instance, attach the volumes back on, and voila, we're good to go. That's a lot faster than trying to unzip and restore a big MySQL database. We also allow our customers, or soon are going to allow our customers, to access all those interesting visual artifacts, the videos and the screenshots, during the test. Because every Amazon instance that you spin up has a good chunk of ephemeral storage attached to it that doesn't necessarily always get used. I think it starts at like 160 gigs, and some of the larger instances are close to 1 terabyte or more. And that was a lot of space for an individual machine to capture videos and screenshots. At a whole, we were capturing 20, 30 terabytes of data, but in terms of the individual machine, it was plenty of space to store that. So we figured, why don't we just put that there? And during the load test, if the customer wants to say, well, what about the second time that timeout happened? Can I look at that screenshot? And our answer would be, yes, you may, as long as the test is run. Once the test is done, we'll shut it all down. And that was basically us taking advantage of all this free storage, terabytes and terabytes, potentially petabytes of data that we could use while our server was still, or while our load test was still running. And then when it shuts down, we just threw it all away. And so we're giving our customers the opportunity to browse that rich visual data and select the things they want to save. And we could let them save 100 or 1,000. Even that's no big deal. It's when you are trying to save 1 million of these things. So that was pretty good. The data dumps are pretty good. They're near instant or as close as EBS snapshots can be. But the biggest problem was, of course, that we're still on EBS. For anyone who got burned by that, they know that risk. Amazon's had some performance issues and some availability issues this year. They've had 2 major outages with EBS. In this case, we said that's an okay thing, because this is a load test. This isn't something that's telling someone when their customer goes, or their website goes offline. This isn't us providing a level of insurance to our customers to say, your website just went down, you're losing tons of money, you need to get on it right away. This is just saying, hey, your load test it's not going to spin up right now. Sorry, come back in an hour and maybe it'll work. And so there's a different level of expectation with this product versus our website monitoring product. So we felt pretty good about relying on EBS for this particular thing. And maybe down the road we won't have any more concerns about it, since Amazon's spending a lot of time on that. So kind of a conclusion, the different storage technologies that we kind of finally ended up with actually aren't that complex. We didn't go build out a Cassandra cluster. We didn't build out, HBase or Shard or MySQL databases, and you can see there we looked at some of those other ones. But we went with pretty much a simple local MySQL database that captured really top-level summary aggregate data. We then would have a second MySQL database dedicated to that customer's load test that would capture all the granular data. And we stored a bunch of extra artifacts in S3. It's kind of just built for that. And so it worked really well for us. Our goals were to give our customer aggregate data as quickly as possible. And so there was no storage system that was necessarily going to make that any faster or easier or more reliable than just a little bit of code that aggregated it up in memory. That's something else to kind of keep in mind, is that sometimes I see folks get lost in the technical details of HBase or Cassandra or Mongo and saying, well, this isn't consistent or this isn't ACID or whatnot. And sometimes that data you can just wrap up yourself. So think about that too. So we looked at a lot of different options, but ultimately we're pretty happy with some pretty basic stuff here. So let's talk about our monitoring. So if anybody has any questions, you're welcome to just raise your hand and I can try to repeat the question. So our monitoring system, this one was kind of a more fun journey. It's kind of a little boring because we ended up right back in some pretty standard technologies, MySQL and whatnot, so I'm giving away the ending right now. But we started with SimpleDB. If you were in the last session, you probably learned a few things about SimpleDB. A couple important definitions, though, that I just want to make. What we call a sample, that's a sample of hitting someone's website, going to, Yahoo, clicking on a couple links, and verifying that everything's working okay. That's what our monitoring product does. That's basically it. We do millions of those every day. A step is kind of like a page view. It's just a way to break up that particular sample into multiple pieces so that you can chart how long does it take for your home page to load versus the login screen to load. And an object, those are all the individual images, style sheets, JavaScript, all the stuff that makes up the page. So we capture all of that. The use case for this product is very heavy to the to writes versus reads. We are inserting data all the time. It's a fairly small but growing trickle of data with the occasional need to read it when our customer says, oh, my website's having problems, let me click on that and drill down, and they'll then run some reports. We started using SimpleDB from the beginning primarily because there was 3 of us and we didn't want to maintain anything on our own. So we said, well, let's take a look at SimpleDB and try that out. And we quickly ran into some performance issues with that. The biggest one being that we had to pretty much shard across a ton of domains because the folks at Amazon would tell us that after about, you might know the numbers more than I remember them, but after a certain size, certain number of items in a domain, they sort of fall over and die, so you need to shard it a little bit more. So we ended up being one of the first folks to break the 1,000 domain barrier a few years back. I guess it was a couple of years, I don't know when it was. But otherwise, it kind of worked. We definitely had this hosted, near zero maintenance database, which was really appealing. But querying the data back out was kind of tough. In a sense, SimpleDB was fast, but it does run into timeouts, and it has limits on how much data it will give you. It'll spend, I think it's 10 seconds. It'll give you as much data as it can, and then it says, okay, here's a token. Ask for some more data. Now that was challenging for us because our customers wanted to get a nice time series graph, and if you're basing a time series graph on that, and you can only fetch half of it in the first 10 seconds, then you got to go back and ask for more. It kind of created this jerky experience for our customers. It also required, if we were going to do any aggregates, and we started playing with aggregations because we needed to make our queries faster, we had to predict what our aggregations were ahead of time. Some of those were easy, average sample response time, no problem, right? But then later customers started saying, well, what about the min and max response time of your DNS lookups for a particular individual object? Oh crap, okay, now we got to start collecting that, and that's the millions of those per hour that are coming in. I couldn't possibly go back and backfill that because the cost, SimpleDB charges by what they call box usage. It's basically CPU time. And the cost of doing that, in our case, because we were, again, this low-cost vendor, would have actually been more than we were charging our customers. So we couldn't go backfill any new aggregate data. We just sort of had to tell our customers, all right, well, hey, we added this new feature, and the charts that show that feature are only going to show up starting today. So that was kind of less than ideal. So we then moved on, and we said, well, what's another hosted database storage that's in the cloud? We want to be in the cloud, but might be a little faster and a little more reliable in terms of getting a large amount of data in a kind of continuous stream. Considering that SimpleDB was kind of a little jerky with some of its timeouts and whatnot. And so right around that time, Amazon contacted us and said, hey, we've got a new beta service called RDS. It's basically MySQL, and we'll host it for you. So we said, okay, that sounds about right. Let's try that out. And so we started storing all new data in there. And that's kind of another thing, too, is as you're going through this evolution, I would encourage everybody here, don't just pick one data set, data storage technology or two, and say that's what we're going to use come hell or high water. It's a journey, and you've got to go through the motions and just figure out what works for you and what doesn't. And it's not just the technology choices, it's the people. And so we had a guy who knew about MySQL, and I said, okay, well, I can do that because I don't know how to really set this thing up. I wouldn't know how to tune it, but hey, I'm Raphael, I'm glad you do, and so you own that now. But we didn't go backfill the data, partly because it was expensive, and partly because we knew this was going to be an evolution. So why not just code into our application, hey, if it's before March 3rd, look in RDS. If it's, if it's after March 3rd, look in RDS. If it's before, go look into SimpleDB. And we promised our customers a 3-month data retention, and really we're trying closer for like 12 months. And so only after about 12 months did we actually go and nuke all of our SimpleDB data. And that may not even happen yet. So we got to get around to that at some point. But only once we've done that, then can we delete that code, the code that does that kind of binary switching of looking where the data is. And that was just a simple, pragmatic option for us because we couldn't possibly move, a terabyte of data in any time-sensitive manner. So why not just work with both, even though we weren't inserting any new data there. One of the nice little things that came out of this is time zones. So time series data is kind of a pain in the butt when it comes to time zones. If you're the type of person who likes to just work in UTC, great, because UTC and any pre-aggregation can all happen in UTC, and you understand that from 16 o'clock to 16 o'clock in military time, that means something, because that's actually, Greenwich time and everything's cool. But we have some customers who said, well, I want it, midnight to midnight, East Coast time. That's what I want my daily summaries to be. And so we tried to kind of address that. And the way we did it is really, really terrible, actually. We used a group by with a date function, which is probably, any of my MySQL people in here are probably thinking, oh my God. But it worked for a while, actually. Where it, there's a laugh out there, it's so bad. She's thinking she should just walk out of here now. She's like, this guy has no credibility. That's all right though, because we didn't know really what we were doing. We were walking through the process, and it worked for a while. It actually, we were storing, millions of records per day. It was adding up, and we kind of just noticed, wow, that's getting slower and slower and slower. And so eventually we said, wow, these object tables, the one where there's like 100x more data than the samples or the steps, those are really killing us. We got to do something about it. Also, like any MySQL-based system or any relational database, if you want to change your schema, that was really difficult too, of course. So, by the way, these are just little screenshots of Amazon's RDS charts they give you for free if you use Amazon RDS. So you can see our free data store on one of our shards. It has about 300 gigabytes of storage. You can just see it kind of just goes down, and that kind of represents our slow and steady trickle. And the CPU, you can see, never really goes up above about 5%. Prior to version 3, which I'll show you in a second, version 2, where we were inserting all this object level data, that was around 100% all the time, because we were trying to pull some data back out when a customer wanted to look at it. It was just really, really bad. So what we did in version 3 was shard the MySQL database. So one problem was that this database was getting too big. Okay, well, let's shard and have lots of small databases. Probably would have been better if we realized we should have sharded earlier on, because just the code that you write tends to work a certain way if you know you're going to shard from the beginning. But we worked around it. You can go and decide to shard down the road. Usually, though, your first shard is like this overgrown beast, and then you got to somehow either break it apart or just deal with the fact that shard 1 is always this terrible legacy shard, and then the rest of the shards are nicer. But again, we didn't migrate at all. There was no migration needed. We just made the code work with what was there and kind of deal with the old data storage and the new data storage. But the biggest change we made is we said, we're not going to store objects, that object level data, which is, there's always way more images and JavaScript files, right, and CSS on a page than there is in than the page itself. There's roughly, we think, about a 50 to 1 ratio, 50 to 100 to 1, depending on the site. And we said, we're just going to actually store that as this format called har. Har is, if you haven't heard of it, it's a JSON structure that Firebug and various other performance tools, web page test if you've gone there and checked it out. It's just a structured data format in JSON that describes how a page loaded. It's that little waterfall in Firebug as JSON. So we just started storing har files, gzipped them, sent them up to S3, and now we're storing millions of those every day instead of putting into a MySQL database. So the good news is that our database was no longer like driving 90 miles an hour towards a brick wall. We were still doing these ridiculous group by date functions, and we knew we needed to do something there. But charting was a lot faster. The only problem is we lost a feature. We couldn't chart that object level data because it was all sitting in these little individually gzip files, and that kind of sucked. But it saved us because we were like days away from totally falling apart. The other thing about RDS is it kind of creates this moral hazard. It makes it so easy to vertically scale up your MySQL instance. We were running these little small instances, and then one day a customer said, hey, that's kind of slow. And you said, okay, we'll fix that for you right now, or this evening in the next maintenance window. And we just went into Amazon's console and we said, okay, next time you do your maintenance window, can you just be a medium instance? And they do it pretty quickly, and our software was designed to deal with the fact that it'd be offline for a minute or so. And then we were running on a medium instance, and the next day the customer would say, hey, that's a lot faster, thanks for doing that. We said, no problem, except on the back end, our cost just doubled. So that created kind of a bad situation for us. We should have sharded, but rather than going through the little extra work of sharding, RDS, I mean, this is a feature, not a bug, so you just got to be careful with it. But it kind of was so tempting to just scale up the instance, and that's one of the biggest challenges with big data is avoid that trap of vertical scaling. And we fell into it, so that was disappointing. But we also had a problem where our agents, there were hundreds of them around the world, were inserting directly into this database, and you can imagine that started running out of connections into the database. So we needed a better design. And RDS also depended on Amazon's EBS file system, and we got burned in the most recent problem where Amazon had trouble. Fortunately, our alerts, our infrastructure for sending out alerts when your site was down, that was still going out fine, but customers couldn't go and get the data and find out why their site was having problems for about, I don't know, I think it was 20 hours when Amazon was having problems. So our kind of last and final one that we're looking at, and there's actually a little bit further we're going to go, is a much more complex architecture that deals with lots of different techniques. So one is we're using SimpleDB not for the raw data storage, but we are using it for the metadata of the monitoring jobs. So when something says, I want to monitor from 5 cities in the US every 15 minutes, we store that in SimpleDB. One of the reasons is just because we trust that in general, Amazon is going to be up more than we are, because they've got thousands of people and we had 3. So we trusted that. We said, you do that and we'll just talk to SimpleDB. And that worked a lot nicer than building our own little RESTful web service that had some of this metadata. We also introduced a result queue model. So we'd use a queuing system. The results would get put into the queue, and then there'd be a single guy or multiple of these guys that would eat off the queue and put into the MySQL sharded databases. And that worked all right. But then we also said, we can't use the EBS anymore. That presented some problems for us. And SSDs, I think there's a couple talks about here about disks, the physical disks and SSDs. They're getting pretty cheap, so why not just buy a bunch of SSDs? So we're looking at that right now. Actually, we haven't rolled that out. But when you look at SSDs, just as an aside, from an IOPS cost, not a size cost, SSDs are ridiculously good value. So keep that in mind. If you're looking for just raw storage, no, but you might want to think about S3 for something like that. But for IOPS, pretty good. So, so that helped us. We also introduced this EC2 instance in front of, it says archive down there in the bottom right-hand side, and that was where we store the HAR files and archive them. And we just stick them onto this ephemeral storage. So we'd still push them out to S3, but then we had a ton of these little JSON files all over the disk. And so we sort of reintroduced object-level charting. Now, granted, it was slower than our sample-level charting, showing you the average sample time or average page load time. But most of our customers told us, hey, if it takes 30 seconds or 90 seconds for a chart like that, that's okay because I'm doing a deep dive analysis and I've kind of pinpointed where I want to be. So if I have to wait a little longer, no problem. So that was a very simple permutation where we're using a combination of solid, reliable storage with S3 plus this ephemeral storage. The only problem with that model is that if that archive cluster falls over, we can bring it back up. We have to fetch all that data back down, and we have so many millions of records that are stored up there. It actually cost us maybe $1,000 or so to bring that back down. Not the end of the world, but something to keep in mind as well when you're looking at data storage techniques, and especially cloud ones. Look at how your architecture and your recovery model fits to the pricing model of the vendor you're working with. So just wrapping up here, finally where we ended up is we've got kind of bare metal. We're back to kind of bare metal MySQL shards holding the data. That's a relatively small amount, 7, 8, 10 million inserts a day. Not something that's crushing that system at all. But by being on SSDs, it can go probably much higher than that, and we're going to be better about sharding things earlier on. All the test artifacts, we store those into Amazon EC2, into S3, and then we put a little set of small instances that have some ephemeral storage in front of that for faster access time, because S3 is pretty slow. You don't want to go and fetch 10,000 objects off of S3 and then work off of them. So it's kind of a front-end cache. It's still a disk cache, but it's a lot faster than S3. We did have our metadata in SimpleDB. We're considering moving that to our own MySQL because we now have a larger team now that we've been acquired. And there's some benefits that come from that. And then also, just a quick little plug, if you don't use it, you might want to think about it. X headers in S3. It's a great little place to just kind of correlate some information with your objects that are in S3. A lot of times people say, oh, I want to put this file here, and I want to store, some little annotation, so I have to have some other database and a web service and whatnot. You can just put a little X header on it and fetch it back down. It works great. So we do that for some data as well. We had a lot of design decisions that influenced this model and this evolution. We're still considering kind of the new kind of NoSQL stuff. And we probably will go there. There's a great talk in the next session, so I'll let you out of here in just 1 second, on OpenTSDB, which is like built for our problem. It's a time series database built on top of HBase. Cassandra and its the counter column type, as well as the automatic expirations that are in there, also works really well with rolling up data and whatnot. So those are things that we were looking at. But remember, we were influenced also not just by the perfect map of the technology to the problem, but how did our team fit into it? And we didn't have any Cassandra experts or HBase experts sitting around. If I could go hire the guy who built OpenTSDB, yeah, we'd probably use that. But you shouldn't feel this strong desire to go towards something if you don't have a guy who can confidently say, I know how this works, my job is on the line, I will support this. That's a really important thing to remember. Dig is a pretty big Cassandra user, or was, and my buddy was on that team. And they had 4 or 5 guys that were committers on the Cassandra project working at Dig. Netflix, going the same model. You want to get that in-house expertise, especially with earlier projects that are evolving so quickly. So just try to keep in mind that picking good technologies for your project is a lot of hard work, and it often goes through an evolution. It's not something you're just going to say, that's what we're going to use, and it's going to work great. This was a quote I actually saw from Hacker News as I was researching for this project, or for this presentation. There was an article submitted. It was a major smackdown. Cassandra versus Mongo versus Couch versus Redis versus React versus HBase versus Membase versus Neo4j comparison. That's a hell of a blog entry. And the discussion on Hacker News had that quote near the top. And it was upvoted for a good reason. That's a really smart quote. Picking these technologies is difficult, and it is a lot of hard work. And it's not something where someone's ever going to be right. It's how it maps to all the elements of your project, not just the problem and how it fits to the technology. Think about development, think about operations, think about what happens when Bob gets hit by a bus. Think about if you can hire the guy who created Mongo. Well, maybe not, because they got a whole company they're doing now, but those are things to consider. So thank you for coming along, and if you have any questions, you can see me after. Thank you.